All right, our project here, I'm Brett Laurie's the principal with Janney Elstner. I'm out of our corporate office in Northbrook. We're a forensic engineering and architecture firm. So we got a little different spin on things, and we wanted to talk about restoring the future. And we put this team together last December. I'll give you a little context and go through our process. First, I want to thank our entire project team. There's 15 of us up here. We've had up to 7 people here this week during the build. It's been a great collaborative process internally for us. We formed this team again in December. We came up with a bunch of different concepts, which I'll go through. And really, it was a group of people everywhere from principal level like myself down to our associate staff. And it's been great from a mentoring and a learning process to go through this. We're all, most of us are preservation architects or engineers, and we focus on restoring the exterior buildings. And, you know, one of the biggest things in the industry right now is cost and time. And so we wanted to come up with a solution to kind of help with that. And John Kraus, I want to thank you for that. I know I pushed you a number of years. I started at ACAW here in 2017. Like Craig, I got a lot of value out of it over the last, 5-6 years we've been involved. And I appreciate you giving the opportunity for the team. So thank you to everybody that's helped with this. I know Andrew did a lot for us. John, Omar, thanks for doing all this. Okay, so I'm going to give a little context. The background behind this is most of the terracotta buildings we work on are, some pre-1900s into the early 1900s. They're all basically a mass of masonry. Some of them in a transitional steel frame building, but it's a massive masonry around a structure. And a lot of times what we've seen is that these are, as John said in his presentation the other day, these things fall apart from a lot of the anchorage and the mild steel that was put in the wall. So in many cases, we're either restoring these or they have been removed from buildings. So as part of our work, we've worked with the International Masonry Institute, which is part of the Bricklayers and Allied Craft Workers. So we're trying to improve the industry. Our team and a number of people from our company are involved with these. We put a number of details together to help the craft workers understand how these assemblies go back together. So this here assembly is using a little bit more modern extruded pieces in a historic wall assembly. And we put together anchorage drawings. And again, a lot of us are into the technical details of anchorage. But we put these together just so that we could help, and we do training sessions with the Allied Craft Workers to help put these components back on buildings. And so here's an example that we did with them. Boston Valley, I know Gladdy McBean, the other manufacturer, was involved in these. And these are in the training centers for the International Masonry Institute. And so on the right of these pictures is your traditional hand-pressed units. And on the left side is a little more of the modern extruded units. But as you can see here, these are very heavy, 1.5-inch thick walled units. These units, some of those cornice pieces probably weigh 300-400 pounds a piece. So it's heavy. It's very taxing on the labor that's putting them in. It's costly. So when these components go bad or they get removed from a building, most of the owners don't want to pay to put them back. So one of the biggest things that we wanted to look at was, how do we reduce the weight? How do we improve the ability to put these on in a timely manner to save on labor? And then there's also the point of, hey, we want to save on material. So let's try to reduce this down. Again, and what we've seen from a lot of our clients is, one, this is the Marquette building in downtown Chicago, built in 1895. You can see in the middle picture there, they took the cornice off the building at one point because of the distress. So the left picture is historic. The cornice was removed. I think it was early 2000s. We ended up putting a panelized GFRC cornice back on the building to make it look right. Okay, that's great. We were able to put that back on, but it was using GFRC, which is not terracotta. We would like to use the historic material and go back with it. So part of this was also come up with a system that was sensitive to the historic nature and using the original material. And what we deal with, there's the traditional hand-pressed units, which we still deal with a lot and replacement. We've tried to do as much as we can from a cost standpoint to go to extruded and ram pressed pieces so it becomes more economical. And now our project is really geared around how can we integrate the newer terracotta rainscreen open joint system and with those extruded products and have the historic look. So here's our team. We got together, we had a historic masonry workshop back in July, and we started working on some of the plans for putting this wall and this assembly together. This all started back in December. Typical components that are bad on a historic building are the corners of the building, the parapet, cornice, and window heads. Those are the three main areas of the building that go bad because they have steel supporting those terracotta elements. So our goal started as we were going to look at different options we were looking at different options of what we could do as far as brainstorming and doing this project. So we had a team that looked at the corner and how we could do that. We had a team that looked at soffit and window heads and how do we hang some of these lightweight pieces. And then we had a team looking at the cornice. And what we settled on was an overall team approach. We all got together and we decided to use some of the detailing that we had put together for the International Masonry Institute. And it's twofold. One, it matches the profiles of what have been put in place from a hand pressed, extruded, and now we can do a newer lightweight system. And it also was to help us potentially train people so that they can put this assembly in and start using it on buildings. So this is the overall profile that we settled on. And it's, again, the pieces are much thicker and larger than what we ended up with. So we started out by, all right, how do we reduce this down? And, I know we talked to John and Andrew quite a bit about this as far as what could we do? What are the possibilities? Because these are all, like the bottom course in there is a new extrusion. The top course is new extrusion. The biggest thing was how do we reduce this down and get the weight out of it? And then we wanted to look at using some of the systems that they already had in place because those are cost effective and they're things that are going on every day at Boston Valley. So here's our overall view of the assembly. We integrated a window opening so we could have a hung soffit unit. We had the profile pieces and we started laying it out with the typical vertical track and clip system. And then we had to come up with a way that we could reduce the weight and put this cornice and hang it on the building. So here's some quick sketches of what our concept ended up resulting in. On the left there, we have a hung piece with some undercut anchors that we use on there. We have the traditional track and clip for the first two courses. And then the big challenge was how do we hang this terracotta cornice piece? And so the first part was the design of the piece. They're all 3/4 inch wide webs and face shells on there. Traditionally, they're 1.5 inches in most extruded units. So we thinned up the material. We also had it so that they could fabricate it on its back and it met within the extrusion parameters that Boston Valley had. So we extruded that piece out. They're 30 inches long. We could probably push it longer than that. I know it starts becoming a weight issue. But the reality was that piece, we reduced the weight by probably close to 70% over a traditional extruded piece or hand press piece. They're probably pretty close. We reduced the weight by about 70%. The other thing in restoration is we have to have ultimate adjustability. These historic buildings are never plumb level. They've moved around over the years. So one of the things that I've heard a lot today is talking about tolerances with terracotta. We're used to dealing with that in restoration and on a mortar set, but dealing with it now with an open joint system, we put in hangers, we put in unistrut and horizontal members in there that would allow us to move those pieces laterally and vertically pretty easily. And it's basically tightening some nuts down and then sliding some clips along the unistrut. Here's a rhino model that Andrew helped us put together with our team, just to kind of give you an overview. Again, these things all change. We had clips put on the back. Inside there's a bar stock that's located within the shells of that cornice piece that we hang it from to give it some capture if something would ever happen. And so we kept tweaking it. How do we get the ultimate flexibility out of it, especially when we were here on the build? I'll just go through these quick. There's a couple of the pictures of us putting this thing together. You could see a little bit there in the background. There's the vertical unistrut and some outriggers. The intent is that we could get these things all tweaked and lined up and basically slide them, slide these two outriggers right onto the backup and not have to adjust it too much. There's the outrigger brackets up at the top. The one on the right there is we were hanging some soffit units. If you go look at the mock-up downstairs in the lobby, you could kind of get down on your hands and knees and look underneath, but we hung those pieces in there so that it looked like a window head assembly. A couple photos looking at the overall. Here's our team. I think we were the first team to wear bring our own t-shirts to the event, so we got some business for that. As you can see, I think looking at this from face on, you'd never know that this was anything more than a historic terracotta cornice on a historic building, and honestly, that was the intent. And we had a little lick'em stickum brick for a little fun. We put some lead coated copper or painted plywood up on top to make it look like a flashing on top of it. Take a look at it. There's some ultimate flexibility with this system. And don't let my father, don't let him know I put lick'em stickum brick on. My dad's a mason. I grew up doing that. So what's next? Our goal is to get this in IMI training centers. You can see here, here's the three versions. We have the hand press, the extruded, and now this rainscreen and more modern system. So our goal is to kind of keep tweaking this. We're also doing an in-house research project at WJE. We have money each year that's allocated to that. We plan to do some impact testing on this because we had some concerns about, window washers and swing stages and things coming down. There's also some, heavy ball impact testing for capture of these pieces. So we got some testing that we're going to do, and we'll continue to put some papers out on this further. But our ultimate goal is get it in the training center so that the craft workers can get it in the wall. And as we got going on this project in December, I did a assessment of the Olympia building down in Miami. It's a 10-story historic 1925 terracotta and brick building. And at the 9th floor, which is the main band that you see about midpoint of that picture, is almost an identical profile to what we just did. And it kind of came upon us as we were doing this. So, you can see the cornice ledge there, and there's a few more pieces of flat ashlars, and then the lowest course in here was a profile piece, but has been chopped off, and they put a piece of cement plaster in there. So here's the historic drawing that we found, and here's the profile of that cornice. So it's pretty close to what we have with an extra, ashlar piece in the middle. So I'm pretty confident we're going to get the design of this in the next couple of weeks, and hopefully we can start integrating in this projects pretty quickly. Again, here's our profile versus that historic drawing. So I thought it was a pretty good opportunity to use it. So I wanted to thank everybody. John, thank you very much for this opportunity to do this. I really appreciate it. It's been a great week. I've met a lot of you, and I don't know, I got a ton of value out of coming to these events and hearing what all of you have. I know this is a little different than most, but hopefully we get this one going in real practice soon. And we did, let's see if this goes. We had a GoPro going with time-lapse photography during our whole event. So this is 2 minutes worth of thing, but we don't have to leave it up. But